Hey guys, today we are talking about the basic vector operation, which is the length or magnitude and the direction. Let me give you an example. For example, the raft motion, like that is the point A, that is the point B, and that is the point C. So the length of the arrow represents the speed. So we can say that at the A point, the speed of the A point is higher than the B point, and the direction is orientation represent the direction. So we can see that A and C have the same direction, but the B have a different direction. Maybe because they have some block or rocks over here. So in our daily life, there are so many situations we can use the vector to represent. For example, the electric and the magnetic field and the flow of air over the airplane wings and the velocity and accelerations. So many things we can describe as the vectors. So today we are talking about how to examine the vectors in the XY plane and extend the concept to the 3 dimensions. Okay, so how to write the vectors? We all know that the vector it's a line, right? So their point is the initial point. So we describe that as the tail. And this point is like ending point. We can also say that is the hand. If we use the number to use the single word characters to point is the P and this point is the Q. So then we write this vector as the PQ. This word P is tail. Q is hand. Okay. Sometimes we also can show that vector as a single character, like U or V. That is the common way to show that. We need to write this one because that is show the direction. Okay, and for sometimes, if we want to see that 2 vector is equal, for example, if the U equal to the V, it means that the V's direction and magnitude is equal to U's, because they're. So we have another things to say is how to classify the vector, the equal vector, and the scalar. And zero vector. How to classify them? The vector, we already say that have the direction and the magnitude, right? Just this point. Equal vectors is the 2 vectors are equal if they have the same magnitude and the direction. Okay, there is questions. These 2 vectors is the same. It's no matter with their position, because we only consider about the direction and the magnitude. The scalar is the common one, just like the quantity have a magnitude but no direction, so we call that scalar. Like just like number, or the temperature, something like that, is no direction. I think that is very important point. Zero vector is very interesting. Okay, let me move that to here. Zero vectors, it has the length 0 and no directions. Okay, so let's move to the next chapter and next scalar multiplication. A scalar C and a vector V can be combined using the scalar vector multiplication, or simply scalar multiplication. The resulting vectors can be written as the CV. If the vector CV have the same direction, if the C bigger than 0, so CV have the same direction. Okay, that is the first precondition. The second precondition is if the C is negative. So CV have opposite direction with V. I think that is easy to understand. Like the C is just a simple number, but they don't have a same direction as the way, but yes. So how to understand the CV? For example, the vector 3 ways means it is 3 times as long as the way and has the same direction as the way. The vector -2 ways is mean that it's twice as long as the way, but it points in the opposite directions. So these two, we can also consider that the 3V and the -2V are the example of the parallel vectors. So what is the parallel vectors? Parallel vectors is each one is a scalar, the multiple of the others. Notice that 2 vectors are parallel if they point in the same directions or if they point in opposite directions. Let me give you an example. The V, that is the V. Okay, the 3V means the direction is the same but 3 times so long, and the 2V from this point to this point. But although the direction is different, it's opposite to each other, but these 3 are parallel vectors. Okay, So that will be giving us the questions about how to describe the magnitude and the direction of the following vectors. There is a question. I will give you guys an example. You can pause the video and to solve that by yourself. Oh, wait. This vector is v and this vector is u, and they are from the original point. Okay, and so how can we? So I will give you several points. The first one, okay, this position is a little bit hard to understand. It's about here. The first one is the point S. Second one is the point R. Third one is the point P. The last one is the point Q. So how do you using the vectors v and u to write the following vectors in terms of the u and v? The first one is the PQ. B is the QP. This one is the QR. This one, last one is RS. Okay. Okay, let me show you the result. The first one, let me to show the PQ vectors first. PQ means the P is the tail and the Q is the hand. And the QP is perfectly opposite with the first one. The Q is not the hand, it's the tail. And the P is the hand. So the first one, PQ, we write in this way. And we can see that it is the exactly same with the vector u. They have the same direction and the same magnitude. So we can write that PQ is u, right? And the QP is the different scenario. Let me to show you first so that the QP is from the Q to the P. That is a vector. It have the same magnitude with the u, but perfectly opposite direction with the u. So QP is negative u. Okay. The third one is the QR. Let me show that. The Q is the tail, the R is the hand. We can see that it have the same direction with the V, but it is 3 times as long than the V. So we can say that the magnitude of the QR are 3 times as long as the V, but the direction is exactly same as the V. So the QR is 3V. The RS from the R to the S, it is in the horizon line, so it should be have some relationship with the U. Okay, the magnitude of the RS is 3 times as long as the U, but they have the opposite direction of the U. So we can write that RS is equal to the negative 3U. Okay. So let's talk about the next one. Choose vector addition and subtraction. Okay, let me to illustrate that by drawing a picture. The first one, like, if that is the vectors VA. The VA represents the plant's airspeed, which is the speed of the plant would have in the still air. Another one is that. Let me write that as the W. It is the velocity of the wind. So that is the VG. The combined effect of the motion of the plant and the wind is the vector sum Vg equal to the Va addition at W. So that is the velocity of the plant relative to the ground. Okay. So how to show that? So we solve the direction of the sum of the vector. So how to calculate the magnitude? Like there are two random. Oh, wait. We use the triangle rule. Is to use this point, that. So that is the U. So we can see that the first vector's hand should be the tail of V. Okay, and the second row is a parallelogram row. Sweet. That is also U. That is using the parallelogram rule. This one using the triangle rule. So what if the U minus V? How to calculate that? How to understand that? We can understand in this way. Yeah, it's the same situation. The UV, if that one is the U, then this one is the V. It means that for this equation, the V should have the same magnitude but opposite directions. So let me to show the negative V first. That is the negative V. So let us find that. That is the U. The hand of U should be the beginning of the second vector, so it should be the tail of the negative v, like this way. So this point is original point for the final vectors, and this one is the hand of the final vectors. So we can show the final vector in this way. That is u minus v. Okay.